Alrighty guys, so now we're going to start chapter 12. In chapter 3, we've learned a lot of, 2 and 3, we've learned a lot of skills that we can use, so we're probably going to be using them. But let's begin 12a. So chapter 12 is about quadratics equation. Okay. Now what that means is it's a power of 2. So it looks something like this. The general quadratics form looks something like this. X squared plus bx plus c equals 0. So as you can see, what that means is, if I kind of just not look at this for now, this equation, hopefully you can kind of see that it's in the equation of the form mx plus c. That's a linear equation, okay, which is a straight line, okay. We've done that in semester 1. Now what we do is we consider another term which has x to the power of 2. And this now gives us a quadratic equation. That looks something like this. So there's two options. We can obviously, because with the linear equation, it could be an increasing one or a decreasing one. So similarly with the quadratics, it could be an increasing one or a decreasing one. So we're going to be looking at functions that looks like this. So that's what a quadratic equation is, and this is the general form. This is what you need to write down in your book, which is exactly the same as this rule I have written down. So this is what you need to write down: quadratic equation, and then ax squared plus bx plus c equals 0. That's the general equation. Now, very importantly, a, b, c are just numbers. We can substitute any numbers. However, important condition, a cannot be 0. So this number over here, which is called the coefficient, right, number in front of x squared, so its coefficient of x squared cannot be 0. Because if it is 0, that whole term will be 0, and therefore we'll have bx plus c equals 0 as our equation, and that's a linear equation. We don't want linear equations because we're looking at quadratics. So the condition is a can be any number, just not 0. It can be negative 100, negative 1,000, positive 100, positive 1,000, whatever you want, just cannot be a 0. So that's a very important thing that you need to be able to tell me. Now, with quadratic equation, well, with linear equations, if we go back to the linear equations, you only have kind of one solution. So you only have x equals something as your answer. With quadratics, the equations that we're looking at now, these are the options. You can have 2, 1, or actually 0 real solutions. So those are our options. You can have 2 real answers, 1 real solutions, or 0 real solutions. And we'll talk about that in a second and show you when you get those answers. So let's have a look at this example. You don't have to know how you get it, but for example, this dot point over here, this is a quadratic equation. In order to know it's a quadratic equation, just the highest power is 2. Okay, so this is in the form of ax squared plus bx plus c. You should be able to identify each of those numbers. So a is 1, b is minus 2, c is minus 8, so you should be able to identify that. Now, an equation like this, you don't have to know how to find it yet, but I'm just showing you that this will have 2 solutions. We'll learn how to solve it in another lesson, or maybe today, I can't remember. And this dot point, let's have a look at this one. So it's x squared, again, a quadratics equation, plus 2x plus 1. This will only actually give you 1 solution, so 1 real solution. However, the last dot point over here, it looks pretty similar, you know. You've got x squared plus 1. We are missing that term. Doesn't matter, still a quadratics equation because we've got x squared. However, this one has no real solution, since x squared is greater than or equal to 0 for all x is in real number. Okay, so we'll explain that a little bit further. Just know that there's the 3 options. We've got 2 solutions, 1 solutions, or no real solutions. Those are our options. And in order to verify that the solution to a quadratic equation are correct, you can substitute them into the equation. So for example, we're going back to this example. Someone told you, or the textbook told you, these are our 2 solutions. X is 4 and x is minus 2. Let's double check that it actually is a solution. So all you have to do is substitute it in. So I write that function over here, and then we say x is 4 because that was one of the solutions that they gave us. So I substitute it in. So instead of writing x, anytime you see an x, you put a 4. So you 4 squared, take 2 times x, take 8. So this will change into 16, take 8, which gives you 0. So yes, this equals definitely 0, which is what we're trying to find. Alright, so this one definitely is a solution. Let's try negative 2. So same solution, if I substitute in -2 into these x's, let's have a look at what happens. -2 squared is 4, -2 times -2 is 4, and then -8 is just -8. 4 plus 4 is 8, 8 minus 8 is 0. So there you go. We want that whole equation, when we substitute a x value in, to turn to be 0. So this is another answer that is correct. Wonderful. So we can always, once we find our solutions, x equals something, we can sub it back in to find our answer, to double check basically to see if it's right or not. Now this is what you really need to write down. So in chapter 7, which you haven't done, so I might just ignore that part. This is just the rule that you need to know. So copy this down in your book right now, please. I'm away, so I can't tell you to do it, but hopefully when I'm back I can check that it's already in your book. So I want you to copy that down first. Pause the video, copy it down first, and I'll explain it. So pause it now, copy it, and then you can annotate as you go. There's basically 3 options, as I said. We've talked about it over here multiple times. So those are our solutions. How many solutions can there be? There could be 2, 1, or 0. So there's 3 types of answers. Again, 2 answers, 1 answer, no real solution. So we're going to show you how that works. So for example, if x squared equals k, then x is going to have 2 answers. This gives you 2 answers. 2 real solutions. I'm just going to write solution as sol with a little n at the top, just as an abbreviation. Because my x can be, what this means is a plus square root k, and x can also be a minus square root k. Rather than writing this whole sentence, we like to just simplify it like so. So you might need to learn how to do that. All you need to do when there's a plus and a minus together, it just means it can be plus and minus. So you've got to write it like this if you want to write it out loud. Write it out. Now, that's the 2 real solutions. So perfect. The next dot point, x is 0. Okay. Oh, so I should really explain. This has 2 solutions if k is greater than 0. So k is this value over here. If this is a positive number, it'll give you 2 real solutions. However, if k is 0, if it says x squared equals 0 for perhaps, it'll give you this answer. Always x will be 0. So this means there's only 1 real solutions over here. In this case, over here, x has no real solutions. Let's have a look at it. K is negative, so k is less than 0 means k is a negative number. If k is a negative number, then, so it'll look something like this, like a -5. So this answer will actually give you no real solutions. Right? It says it all there. So all you need to do, okay, is copy down. I might just, get rid of all the highlighters and stuff like that because it's just messy. I want you to copy all of this down because this is the note that we will be looking back to in order to find our answers. And I'll show you how to do that. I'm just going to skip that, but let's try example 1. I'll leave that there so we can refer back to it. So let's solve for x. Copy it down in your book. Please write example 1. And we'll write it as neat as we can and put a highlighter box around it because it's an example that we want to refer back to. So everyone copy it down. Then what we're going to do is we want to solve x. Now what that means is you basically want x by itself. So everything else is on the right hand side. X should just be on the left hand side. So basically I need to remove everything that's attached to x. So at the moment, there's x on my left hand side, so I need to basically get rid of the 1, the 2, and the square, I should say. So which one do I get rid of first? Well, think about the way how this is done. X is squared first, then 2 is times, and then 1 is added. So you undo it going backwards. So you do -1 first. Hopefully you are very aware of that method because we have practiced it so many times in semester 1. If you need extra practice, please let me know. So this will be 15 take 1, which is 14. Now all I need to do is decide if I want to get rid of the squared or the 2 first. Hopefully you understand that you actually need to divide 2 first before you get rid of the squared. So x squared, because these 2 cancel out, is 14 divided by 7, which is 7. So this is what I have. Okay, I have x squared equals 7. So have a look. Obviously, I know that I need to square root it because that's how I get x by itself. Now, when you square root a number, you should always understand that you have 2 solutions. You have a plus solution and a minus solution. So this is your answer, and as you can see, it agrees with this answer. My k value, right, k value, x squared equals k, x squared equals k, it looked like, I know it's got a bit messy because I put a square root over it, was a positive number. So because k was a positive, this should be what my answer looks like. So I should be able to have exactly the same. So plus or minus k, square root k, plus or minus square root 7. Brilliant. So that is my answer. If I want to write it out, basically what this means is, as I said, x can be plus square root 7 or minus square root 7. Those are your two answers. So you have two real solution. All right, let's try B. Please copy that down. So now we begin to do this side. I'm going to copy it down first so we can do some working out. Hopefully you can see that in order to have x by itself, first of all, you need to get rid of the squared. So we'll square root both sides. Now when you square root, all I have on the left-hand side is x take 3. On the right-hand side, remember that anytime I add a square root, I have to write it as a plus or minus answer. Now, plus or minus square root 16. Square root 16, well, 16 is a perfect square number. So hopefully you understand, and I don't have to tell you, that it simplifies down to just 4. Square root of 16 is 4. Still, there's a plus and a minus option of 4 as well. Almost done. Technically, I could just not write this brackets because there's nothing else, that needs to be done. I almost have x by itself. I just have to make sure the plus minus 3 goes away by doing plus 3. Okay. Now, I wrote it at the back, but there's a nicer way to write this answer. I like to write 3 at the front and then write plus or minus 4. And we can just do the calculation and find the answer. So let's do 3 plus 4, which is 7. That's one of my answers. The other answer is going to be 3 minus 4. So I've considered the plus, now I consider the minus. 3 minus 4 is minus 1. So therefore, I'll write my final answer. X can be 7 or minus 1. As you can see over here, there was 2 real solution for this one as well. Cool. Let's have a look at C. So I've got x plus 2 squared equals 11. So let's square root that square to get rid of it. So I have x plus 2 equals plus or minus square root 11. Remember the plus or minus. Now we move on to the next part. So again, I don't really technically have to write the brackets. And then I just do take 2 on both sides. Now, as I said, you could chuck it at the end, the minus 2, but I like to write it at the front, in front of the plus or minus. So you could chuck it in the calculator, but I'm just going to leave it in the exact solution. So if I want to write my final answer, I just write the 2 options. So it's minus 2 plus square root 11 is one of the options, or it's minus 2 minus square root 11 as the other answer. So again, this one had 2 real solutions. So if you would like to put them in the calculator and tell me what you get as decimal points, you're more than welcome to. But as I said, when we do these sort of questions, unless it says, round to 2 decimal places or something like that, and it specifically asks for a decimal answer, you really want to just leave it in the exact forms, and I want you to practice that. So please copy all of that down. You are more than welcome to give these questions a go. So I've already copied and pasted for you to make it a little bit easy. So you should be able to do the last 2 rows for each question. So these ones, I really want you to practice them, guys. Okay, some of them might be a little tricky, so do your best. Do some for homework if you don't finish it in class, and then I want you to show me tomorrow and ask questions if you struggled with it. 3, I might give you a bit of a tip. I want you to do every single one. Okay, maybe I'll circle them just so it doesn't look so confusing. I want you to do every single one for 3 because the fractions make it hard, and I want you to practice them. And I will give you a little tip. Now, when there's a fraction, you start by cross multiplying. So I'll kind of start you off with A. So you've got solve first x for x by first eliminating the algebraic fraction. So we don't want it in a fraction form anymore. So if I want to solve this, I do cross multiply, and you can do that for every question. So you times the diagonals is how it works. So you times this diagonal, so x times x is x squared. And then you write equals and then write the other diagonal. So that's how you do cross multiplication. So 4 times 1. So that will be 4, and you should be able to solve this. Oh, maybe might as well just finish this one for you, and then you can do B and C. So in order to get x by itself, I just square root. So my answer is x is plus or minus square root 4, which I know what it is because it's a perfect square number. These are my answers. X is plus 2 or minus 2. So you should be able to do question B and C. I want you to do all of this and make sure you finish it for homework, please. Check all your solutions. Good luck.